going to talk about vectors. There's a lot of different parts to this. I'm just going to make our I can statement easy to remember, as we're going to apply properties of vectors. There's a little more to it than that. Simplistic statement, but that pretty much covers it. All right, a vector. I'm actually going to pause this, copy it down. So it's a quantity that has both magnitude and direction. The magnitude is represented by the length of the vector. So this half arrow looking thing on top of the A here, or on top of the PQ here, is a vector symbol. Absolute value means distance. Okay? And so if they want the magnitude, they would write it as the absolute value of vector A or the absolute value of vector PQ. And over here in the picture, I've labeled this both ways. If I put an A in the middle of it with a little vector symbol over it, that means that's vector A. Or if I label both ends of my vector, P and Q, then that, I could label that vector PQ. Okay? Direction is indicated by the arrow on the vector. Or on the coordinate plane, the direction is the angle between the vector and the positive x-axis. So in this picture, we have vector B on the coordinate plane. The angle between the positive x-axis and the vector is this angle here. And if that's 45 degrees, then the angle of the direction on that would be 45 degrees. Okay? So if both the initial and terminal points of a vector are at the origin, then it's a zero vector. If both the beginning and the ending of the vector are at the origin, then there is no length to it. And it wouldn't matter what direction you're going in, it still would be called a zero vector. Two vectors are equal if and only if they have the same magnitude and direction. And it's key you understand they have to have and there. They have to have the same magnitude and the same direction. They don't have to be sitting in the same place, but they have to have the same magnitude and the same direction. An example of this those two vectors are equal. They have exactly the same length. They're going exactly the same direction. If I placed them on top of each other, they would be identical. Okay? So those are equal vectors. If I put together a coordinate plane on here, and I did the same thing over here, and this is something you'll have to do from time to time. This angle and this angle would be the same because they have the same direction. Okay? So those two vectors may not be exactly in the same place, but they're equal because they have the same length and they have the same direction, same magnitude, same direction. Okay? The sum of two or more vectors is called the resultant. In geometry, we had coordinates. We've had vector coordinates, and we added the x coordinates, we added the y coordinates, and we found the resultant that way. In geometry, or in trig, we're going to end up using finding the angles and using our trig from time to time, our sine, cosine, tangent, whatever's necessary to help us find some of these things. That's what makes this a little different level than what you learn in geometry. But the tip to tail method, the triangle method we're talking about here, is if I moved one of these vectors so that the tip of this bottom vector here was touching the, let's call this R, let's call this R, vector R, and vector S. And we want to find out, we want to find vector T, which is equal to vector R plus vector S. Okay? Well, vector T is going to be this vector right there. So this would be T out here. So T is the resultant. In other words, they're asking is, if I put these two together, what would be a single vector that would represent where I started from to where I ended? In the two red ones, R and S, I started here, and I went to here, and then I went to here. Well, the resultant is going to be, if I just want one vector that represents where I started and where I ended, that's the black vector here, vector T, that starts here, ends there. Okay, so the resultant shows where did you really start and end if you apply those two or more vectors. Okay, and you'll have some practice moving them around, combining them. They'll give you a list of vectors, and you'll have to copy them and find their angles, and you have to make the angles stay the same. You'll have to move them around and find the resultant. Okay? All right. Two vectors are opposite vectors if they have the same magnitude but opposite directions. So opposite vectors have the same magnitude but opposite directions. So a quantity with only magnitude is called a scalar quantity. Examples of scalars include mass, length, time, temperature. Okay? Two or more vectors are parallel if and only if they have the same or opposite directions. So if two vectors have the same direction, they're parallel. If they're opposite in direction, they would still be parallel. So two or more vectors whose sum is a given resultant are called components of that resultant. So if we went back to that other picture where the two red vectors added up to the black vector, vector R and vector S added up to vector T, then vector R and vector S would be considered components of vector T. Okay? I'll look at the homework here in just a second to see if we have any examples that I want to do. Let me double check what I have for. Pause here so I do that. So our assignment today is 15 to 37 odds. I'll start updating the calendar on Schoology, and I'll have your test done tomorrow.